So today I'm gonna talk a little bit of like how we're building the data pipelines with Druid at Lyft. And a little about me, so I'm working at the data infrastructure team at Lyft, and I've been in the team since 2019. And our team mainly working on Druid and the Trino, which is also known as Presto, but they rebranded it, yeah. So in the next like 15 or 20 minutes, I'll briefly talk about like first why we're basically using Druid at Lyft, and then like I would like talk a little bit of like how we're building the ingestion pipeline at Lyft and how we set up those stuff, and how we like set up our Druid system here, and also like I'll like briefly talk about 3 typical use cases here at Lyft. And first, I'm gonna talk about like why we're basically using Druid at Lyft. So our company's mission is to basically improve people's life with the best transportation. So there are like we will have to use a lot of like data analytics, and we find that like that with Druid, like especially the support for the timestamp data, it like best fit for our like business needs, especially when it comes to the real time like geospatial data for the market analysis, and also we can use Druid to build like a fast internal tooling for data exploration and visualization. And also we do a lot of like comparison. When we compare it with some like hot names like the Trino, Presto, it like we find that it can achieve the better like query performance, and it's like basically our teams owns both the Druid and the Trino, and we find it's 10 times faster on average. And that's because like we kind of use those like memory data caching without like having to shifting those like among different like serving nodes, and also it used the direct memory map, which helps a lot. And also when it comes to comparison with equivalent query latency databases like the DynamoDBs, and we find the cost is much less than like DynamoDB. And also like the Druid is like pretty reliable, and it can also support us with different tiering so that we can provide different stuff for our customers. And also we find it can like horizontally scale pretty well. And the support for the query and ingestion also allowed us to like build a very reliable infrastructure around it. So next I'm gonna like talk a little bit of how we build the ingestion pipeline here. So here we have like 2 kinds of the ingestion. One is we use the Airflow and the Hadoop to basically building the batch ingestion on top of Druid. And also we use the Flink application and Kafka to build the real-time ingestion pipeline. And so this is a diagram that basically tells us how we do the real-time ingestion. So in Lyft, we had a lot of the like clients, applications, or services which generate a lot of the analytics event. And basically, those events are loaded into Kinesis services. And we had a like service called Lyft Fanner, which basically does a lot of the pre-processing for those analytics events. And then like it got loaded to the Kinesis. And we, on our side, basically we spin up a Flink application, which uses the Kinesis as the upper stream, and does a bunch of the pre-processing, which includes like data enrichment, and also use the Flink SQL to do a bunch of the transformation, and also use like the UDF to do also those like transportation, and also do the sampling and the filtering. And those like data coming from the Kinesis are in JSON format, and we transform it into the portable format, and then like send it to the Kafka. So basically on the Kafka side, we do like a 1-to-1 mapping, which means that one Kafka topic maps to one data sources at Druid. And basically on the Druid side, we use the Kafka connector to like get those like data coming from the Kafka. And basically we use like a custom the row passer to deserialize based on the port above message. And that can also like kind of support for the schema evaluation. And apart from our Flink application to do those like real-time ingestion, we also allow our customers to spin up their own Flink application and load the data into Kafka, which it will later be picked up by Druid. And apart from that, we also had a service called like Druid Controller. What it does is basically it enabled us to like send a bunch of the supervisor to the overlords so that it can kick off those like real-time ingestion jobs. And yeah, so like next I'm gonna talk a little about like what's the steps for us to basically onboard a user for their like real-time event. So basically the user will have to like defining a portal bus for their desired table, basically their desired data sources. And like this is you can see like this is about like geohash information. And next we will allow the user to defining their like transformations or data enrichment they would like. For example, here the example is that it will do the geohash transformation for the incoming event. And those are basically we make full use of the Flink SQL. And next, we're gonna like specify configuration files. So basically, in this file, it will contain information like for the data sources, which will eventually land at Druid. What's the timestamp column, and what's the like the dimension columns, and what's the matrix columns here. And also, it will like identifying the segment granularity and query granularity. And also, like one thing important is that it will also like identify itself like which port above message it will like look up to, so that it can like allows the Druid to deserialize those information. So like apart from that, we also had like this. The last step is actually in our Druid controller. Basically, it will trigger the event ingestion into Druid after we specify all those like configuration. So basically, it submit like supervisor configuration to the Druid overlord, and which automatically does at the deployment stage, which will after like submitting it, it will like start the ingestion immediately. So next, I'm gonna like talk about like how we do the batch ingestion. So in Lyft, we use the Airflow to do a lot of the ETL works, to do the scheduling works, and like for like the batch ingestion for Druid, we're basically defining a bunch of the specific DAGs, which like what the DAG does is like first like submitting those like jobs to the Druid overlord, which will have those like tasks running at the middle manager, and like for each task, basically it will like kick off those like jobs in like in Hadoop, and there are like three like typical types for those like batch ingestion. One is that we use the batch ingestion to ingest massive offline data. For example, we collect a lot of like infra-spanning information, and we use the batch ingestion pipeline to do so. And this job basically like ETL is kind of, you can think of it kind of like ETL works to basically load the information from Hive to Druid, because like Druid has like a faster query like performance. And also we use batch ingestion for backfill if there's any like failure at the real-time ingestion pipeline. So this way we can avoid any data losses. So, and also we use the batch ingestion for compaction works. Basically, this allows us to significantly reduce the segment numbers and also the overall size of those like segments. So there are like a lot of like benefits we can get from the batch ingestion. First, it can like significantly improve the query performance, because with the batch ingestion, the data are better aggregated. And also we can have like a fewer segments and overall smaller size. And it can also like improve the system reliability. We find out that with fewer segment numbers, the historical nodes like bootstrap times like significantly reduced. And also it can save a lot of like cost for the storage. So next I'm gonna talk about like how we set up Druid at Lyft. So basically, we used the open source fork and generate a Debian package, and then like deploy to a set of Lyft Kubernetes pods. So at Lyft, we basically have another team that's building the Kubernetes stuff on top of the EC2 instances. And at the prior to 2021, like all those like Druid stuff are directly deployed to EC2 instances. And starting from the beginning of 2021, we successfully migrated everything to Kubernetes. And for the those configuration of the Druid, basically we try to have the similar CPU and memory as the previous EC2 instances. And there's two things I would like to brought up here. One is we're basically using tiering for historical and the broker. This is we had hot tier broker and hot tier historical, specifically serving for use cases which requires tighter SLOs. And another thing I want to call is that we used the router here in the front of the broker. This is not for every cases, but we use the router to directly connect with Mode, which is another third-party visualization tool. And basically, we used the Avatica JDBC driver on top of it. And also, we used the MySQL to basically store the Druid metadata information and the Zookeeper and S3 as the deep storage, and the Flink and the Kafka for real-time ingestion. So next, I'm gonna talk those three typical use cases that we use Druid for. One is that at Lyft, we use Druid to build interactive dashboards. And here is an example of we used it for the geospatial data lookups. At Lyft, we had some requirement from the operator, which they would like to find specific drivers within a given geohash information. So previously, they used DynamoDB to basically store the location information of the last 3 months data, and they find out it's pretty expensive, and we basically helping them to migrating to the Druid, which saves millions of the cost annually. And you can see this is simply time series data modeling with the user, with the operator basically typing what's the time range and what's the geospatial they selected, and it will return them the qualified drivers with those informations. And for this use cases, basically it has hundreds of thousands of records to be ingested per second, and it can achieve the P50 square latency is less than 100 milliseconds, and P90 square latency is less than 200 milliseconds. And because those data are ingested through our real-time ingestion pipeline, the data freshness is pretty low. It's basically less than 1 minute. And another use case is that we use Druid to build the data exploration and analytics and tracking it. So here is dashboard, or I would say a report, visualization report for tracking different infra span across different teams, across different applications, different services. So this is actually a mode report, and it's constructed those with the data on top of the Druid. And we use the Avatica JDBC and connect with the mode bridge, and then have the query came in at the router, which will be distributed to the broker. And those data are actually ingested daily throughout our batch ingestion pipeline. And basically what it does is does a bunch of the select and use the ETLs to load the data from Hive to Druid. And why we, for reasons why we not building those data directly on top of the Hive data is because Hive query is significantly slower than having query running on Druid. So basically the P99 query latency is less than 1 second, and our user can quickly retrieve those infra span information to track the overall spanning. So next use case is that we use Druid for the market forecasting model. So this is a very, I would say very specific or tricky use cases here, because we had customers which used Druid to do the prediction, which basically predicted the to predict the price based on a lot of a business metric, the rideshare demanding pricing information like that. And they would like to have ingesting data freshness to be less than 10 seconds because they mainly focusing on last n hours data, especially last 5 minutes once. And their ingestion volume is pretty high, and those data are generated throughout their machine learning model, and they will also use it to do the prediction. And we basically did a bunch of the analysis and find out Druid is when we use Druid, it can save about 40 times cheaper than using the DynamoDB. And also, in order to support their specific use cases, we basically provide a dedicated hot tier brokers and hot tier historical nodes for them. Basically, that can achieve the resource isolation to making sure that our existing use cases are not being affected by this, and we can tuning those configuration specifically for them to achieve their SLOs. So basically, their query latency can achieve less than P99 query latency is less than 500 milliseconds. So yeah, I think that's pretty much all. Yeah.